Hey guys, how are you? I'm here to solve another problem. This problem would be number 78 from chapter 4. 78 from chapter 4, page 201. But first, let me introduce again reference book, which is Heat Transfer 10th edition from J.P. Holman. Okay, this book has a lot of interesting chapter. First is introduction, second steady state condition on one dimension, and third is multiple dimension. And chapter 4, which we are gonna work on that and solving the problem of this chapter, is unsteady state condition. For example, in transient condition. Okay, so let us go back to our problem. Page 201. Okay, let me close that page. 78. Okay, let us read it together. Write the nodal equation and establish the stability criteria for node 1. Where is node 1 here? In this figure P474, which is this picture, at transient analysis, and material A and B have the properties given in problem 73, which we're gonna go to that and let's see what is happening in that. But first, let me check something. Okay. Okay, everything is great. Then let me continue. Okay. Let me just draw this picture again. Here. Okay. Here we have some water, okay, or some fluid. We don't know what is it there. Okay. Then T infinity is 30 degrees Celsius. And H is 40 watt per meter square degree Celsius, which is so high. Okay. And what another point? This is point 1. This is point 2. Point 3 is here, and point 4 is here, and just solid line here. Okay, just these 1, 2, 3, and 4 points. Okay, so what is this distance? 4 centimeters. 4 centimeters too. And this is 2 centimeters. Okay, so let us, this is this one. This one is material A, and this one is material B, and this is some isolated. Okay, so let's go to for solve this problem. Okay, very good, excellent. Let me go to problem 73, which is here. Okay, we have this material here. Okay, this material, we have the material of this problem here. Okay, and Okay. As I talked to you before, we have a formula which is delta T smaller or equal to what? To Ci divided by sigma j 1 over Rij. Okay, this is the formula. We should use and calculate this formula for just 4.1. Okay, so let's do it. 1 over R1 2. It means the resistance R is resistance from 1.1 to 0.2. Okay, this resistance. But first, let me divide these elements. For point 1, we have the element something element like this. Okay, this is 4.1. For point 3, what do we have here? And I don't know what is the next point, so we don't need it. Okay, and for this is the actually, let me draw it from top a little more, and I think this is 4.2, and this would be 4.4, and of course this is 4.3. Okay, but the element we needed here in this problem to solve the problem just is this element. Okay, and this is 0.2. So half of them is in material A and half of that is in material B. Okay, let's do it. Let's calculate R 1 over R1 to 2. Okay, what was the formula? K A delta X. What is K? K in actually in the here, K for material A. It has two sections. So let me write it another time. 1, 2. Section A, this is section for section B. Okay? So what do we should here? What do we should use here for K? 20, because this is A. 20 here, you can see it for A. Okay? For A, we have, let me highlight it to, you can see it. Okay? 20 multiplied by A. What is the A of that? A here, 4 centimeters. Okay? But in material A, we have just from here to here, which is 2 centimeters. Okay? 2 centimeters divided by delta X from point 1 to 2, which is 2 centimeters. Okay? The answer would be 20. And we should write it exactly for this is B, this is A, delta X equals K here is 1.2. A is equal than previous one, and delta X is equal previous one too. The answer will be 1.2. Okay, this is for points 1 to 2. Okay, but we should write it. Write the R1 to 3. R1 to 3. Okay, this is point 3 and this is element 3. And resistance from point 1 to 3. We should write it, which is in material A. Ka delta Y, because from point 1 to 3 we have delta Y equals the conductivity is 20. Okay, as you can see in the table in the right in right side of the window, you can see it, which is exactly this one. Okay, to what is A from here to here. Okay, So it should be 1 centimeters. This is in meter. Okay. Delta y. What is delta y? Delta y from here to here. 4. Okay. 4 centimeters. The answer will be 5. Okay. What do we shoot anymore? What do we shoot else? What do we have else? On 1 over R 1 to 4. Okay, K A delta Y. Which K? KA or KB? From 1 to 4. This is 1.1, 0.2, 0.3, 0.4. Material B. So this is K for point B. Okay? Equals. What is K of material A is 0.1, 0.2. Okay? Is that right? And what is A of that? Here, from here to here. Okay? This is 2 centimeters. Then it should be 1 centimeters. Okay, divided by delta Y. What is delta Y? 4 centimeters. Okay, 4 centimeters. And the answer would be, answer is 0.3. Okay, 0.3. And what is the difference between two? The conductivity. This is 20 and this is 1.2. Okay. And what do we have? From we wrote it from 1 to 2 because it had 2 sections. From point 1 to 3, 1 section. Point 2 from point 1 to 4, and another one from convection here. And this is isolated. We don't have any transfer here from point 1 to this zone, but we have some convection here. Okay, we should write it in this way, 1 to infinity. Okay, but the formula is HA. Okay, H is heat transfer coefficient, which is 40. Okay, 40 to A. What is A between element 1 and this convection? Just here, exactly here. Okay, what is the number and the value of that? 2 centimeters. Okay, is it right? The answer will be 0.8. Okay, these are resistance of 0.1 as we discussed before. But we should calculate this one, the denominator of 0.1. Then let me write it sigma j, 1 over R1 j equals, okay, if I plus all of these values together, the answer would be 27.3. Let me write it again with another color. 27.3. Okay, so this is good. And what else I should calculate? CI. Okay, great so far. What is the formula for CI? Rho Cp, which is heat capacity. What is rho? Density of material. And delta V. V is volume of each element. Okay, so you can see in a table in right side of the picture of the window everything about density and C, and we don't have delta V, but we can calculate it from the picture. So let us do it. Okay, just wanted for 0.1, C1, rho 1, Cp. It's better to say yeah, because it has 2 sections. We should write it for 2 points, A and B. Okay, 2 sections. CP1 and delta V1 plus rho 2 CP2 for another material and delta V2, okay, equals, we should calculate here, okay, for A, this is A and this is B, material A and material B, okay? So what is rho 1 for material A? In the, you can see at the table, rho is 7,800, okay? Multiply by CP, what is CP of that? 0.46, is it true? But this value is in, pay attention, in kilojoule. We want it to in, actually we want it in joule per kilogram centigrade. You should multiply by 1000, okay? And delta V, what is delta V of that? Delta V of this section, which is the value of that, okay? 1 centimeters here and 2 centimeters here, okay? So 1 centimeters multiplied by 2 centimeters. This is volume, and of course we need a 1 here because we assume that this is y-axis, this is x-axis, and this is z-axis. And the number, our value in z-axis is 1. We assume all of it is 1. Okay, so we don't need to write it. Okay, it was for material A. But what do I should write for material B? Again, density for material I, you can see it 1600. Okay, 1600. Multiply by what? By 0.85. Of course, multiply by 1000. And volume of element exactly like section 1. Am I right? 1 centimeters multiplied by 2 centimeters. Okay? This is 2. Two centimeters. The answer, if you calculate all of these numbers, plus and multiply to each other, the answer will be 989.6. Okay? This is C1. This is C1. The value for C1 is this one. So where were our formula? Here. We know C1, we know sigma j 1 over R capital IJ for 0.1. We can calculate delta T now, okay? So what is the value of delta T, by the way? Delta T should be smaller than CI. 989.6 over this one, 27.3. If you divide this number to this one, the answer will be 36.25 seconds. Okay, this is our answer, 36. So what we can use this for what? There is a formula. I can write it to calculate transient calculation and simulation. Okay. Okay, what is that formula? T1 Ti P plus 1 equals Qi plus sigma J Tj or R1J. This is 4.4 times P. Okay, multiplied by delta tau Ci plus 1 minus delta tau Ci sigma 1 over Rij TIP. Okay, this is our formula. For example, we have time and location. What are our location? 4 points. Point 1, point 2, point 3, and point 4. We just have point 4. We just have 4 points. Okay? And the time. 0, time 1, 2, 3, and so on. So what is this step of time? Delta t is 36.25 seconds. So in first, when in t node or t0, the time is 0. In t1, what is the time? 36.25. In t2, which is this one, what is the time? 2 multiplied by 36.25 and so on. Okay, we can understand all of these times from this formula. Okay, all of this from this formula. Okay, so P located from time, P plus 1. If P will be 0, if P is 0, the time is T1, okay? And so on. So we should know T in this time to understand temperature of this time, okay? We know it. We know this one. What is T0? Sorry, this is not 0 exactly. This is number of that, okay? The P is 0. P is 0. What is the TO? Temperature, of course. Temperature. Temperature at T0. What is the value of that? We go back to our problem 78. Okay. Oh no, we don't have it. We don't have the temperature. What temperature of this one? Okay. 73. Maybe it is done in. No. We don't know it. We don't know exactly the first temperature of that one. If we knew it, it would be we would be able to understand time. We imagine that, for example, its temperature in T0 will be 2000 degrees Celsius. Okay, this would be our I will be for just 0.1, and then T 0, 1 will be 2000 degrees Celsius. This is okay. We want to know T1 1. We can understand it from this one. And after that, T1 2. When we find this one, we can understand what is the value of this one, and so on. Okay? So let me just write one of these. T1 0 plus 1 would be 1 equals. We don't have Q here. This is 0. In this problem, Q is 0. Okay, what is this one? We should know temperature of all the points. And imagine all of them would be 200 degrees Celsius. 1 equals T20 equals T30 equals T40 equals 200 degrees Celsius. Okay, this one. And we should put it in this formula. Okay, 200 multiplied by the R, and I deleted it, I erased it, because for example, you imagine R1 to point 2, point 1 to point 2, we had two sections. We had two sections of that. For example, a number here, and so on. Okay, delta T, which is 36.25, CI, which was, I erased it, CI, and so on. This is not so difficult. Okay, we can understand T1 first. After that, okay, T11, and then we should understand T12, and so on. Okay, it was this problem, the solution of this problem. Thank you for watching, and take care, have a good time, and bye bye.